Okay, so this lesson is not going to be very different from yesterday's lesson. The difference is now I'm going to give directions on the bearing. So I'm going to be specific. Before there was no directions given. They're just saying they'd say something like a bearing from A to B, and then we just make our north line and draw our sort of angle clockwise. But now we're going to have a specific direction. So if we want to draw a bearing with a specific direction, for example, north 30 degrees east, what we're going to do is we have our starting point, and we always use our north-south line as our reference line. And then we're going 30 degrees east. Remember, no, never eat soggy waffles, right? So if we're going northeast, I'm going up and to the right. So this would be a bearing of n 30 degrees east. So you all try a bearing of north 20 degrees west. Perry, AirPods out. Augie, stop touching him. Okay. All right, so what would this look like? If we're north 20 degrees west, we have our north-south line, and we're going up, but this time instead of going to the right, we're going to the left. So that would be this angle. Okay. Now I saw that you were in the nurse. Matisse, did you do your homework?
Yeah.
You did? Okay. Show me after the lesson. So now we're south 50 degrees west. So again, we use our north-south line. But this time I'm not going up. This time I'm going down and to the left. So that would be this bearing right there. All right, are we ready to do some word problems? All right, so it says the bearing from A to B is north 65 degrees east, and from B to C is south 25 degrees east. The distance from A to B is 100. From B to C is 150. So this is a two-part problem. Find the distance from A to C and the bearing from A to C. There'll definitely be a question like this on your test where I'm asking for the distance and the bearing. So let's see how we go about this. One step at a time. The bearing from A to B is north 65 degrees east. So it's from A, right? Wherever it says from, that's your starting point. So here's my A, and I'm using my north line and I'm going east 65 degrees. And this is 2B. Then it says from B to C. So wherever it says from, that's where we're starting. So from B to C is south 25 degrees east. So now we're going south. There's my reference, and east. So let's see. Find the the distance from A to B is 100, so we'll label that. And from B to C is 150. Find the distance from A to C first. So I'm finding this first. Now, remember I told you in all of these problems, we end up with what kind of angle in the triangle? A right one. It's just a matter of finding it. Now, I definitely have a north line and I have a south line. Well, aren't north line and a south line, if I extend them both, wouldn't they be parallel? So those are my two parallel lines. So knowing those two lines are parallel, can anybody find an angle measurement within the triangle using the parallel lines? Evie?
65.
Yeah. On that other angle by B, that's 65 degrees. Why, Evie?
Because the two insides are
Yeah, so right here, do you guys see the Z? The angles in the armpits of the Z are congruent. Does anybody remember what they're called? Is that it? Alternate interior angles. You got it. Alternate interior angles. All right. So with that said, now that I know that angle B is split into 65 and 25, isn't that 90 degrees right there? So this wasn't so bad. Here's my 90-degree angle. I have A, B, C. The first thing I want to do is find the distance from A to C, which I will call X. A to B is 100. B to C is 150. Do I need to find an angle measurement to solve this? No, what can I use? Pythagorean theorem, you got it. So I'm going to say 100 squared plus 150 squared is equal to x squared. I'm going to take this a step further before I go to my calculator. Do you all agree that x will equal the square root of 100 squared plus 150 squared? So I'm actually going to type this whole thing into my calculator. So let's go to the calculator. So we have second square root, and now I need parentheses. So I'm going to say 100 squared plus 150 squared. And then I will close up my parentheses and press enter. Let's go, I didn't say in the problem, but let's go 3 decimal places. So 180.278. We're not done. That was just part A. So now what we want to do is we want to find the bearing from A to C. Okay, well, I said I think the bearing's already there. Do you guys agree? From A to C, we have to use the north-south line, right? So it looks like it's this whole angle right here. So now that whole angle is split into 2. I have the 65 degrees, but do I have this bottom angle? No, but using this triangle that I have here, can I find this bottom angle? Absolutely. Let's go ahead and call it theta. I'm going to use the 150, which is opposite, and the 100, which is adjacent. So we are a tangent of theta equals 150 over 100. So theta will equal the inverse of tangent of 150 over 100. Let's do this in degrees and minutes, just for fun. Let's do this in degrees and minutes. So to find this in degrees and minutes, we're going to do second tangent, 150 divided by 100. Close. Can I press enter if I'm doing degrees and minutes? No. We're going to press second apps and choose number 4. Now we press enter. So what do we think? 56 degrees and what? 19 minutes. So now if I were to add this bearing, these two angles to find the bearing, it's going to be 65 plus 56. Did anybody add these? 121 degrees and 19 minutes. Okay, something you need to know. Star. Bearing direction should always be an acute angle. So what does that mean? Bearing direction should always be an acute angle. Well, 121 is definitely not an acute angle. So what we did was we took the bearing from the north line. But wouldn't there also be another bearing from the south line? So that's the one we want if that's going to make it the acute angle. So if I extend this, and now I want this angle, call it Y, I want that bearing from the south line to south. So how will I find this? If I know this angle is 121.19, subtract from 180, you got it. So we're going to do, let me bring it over here. Bearing will be 180 minus 121 degrees and 19 minutes. Can I subtract in this format? No, I have to change them both into degrees and minutes. So this is going to be 179 degrees and 60 minutes minus 121 degrees and 19 minutes, which will end up giving us 58 degrees and 69. Nope, that's wrong. 58 degrees and 41 minutes. Does that sound better? All right, let's do another one. How about you guys try the setup for this? Even if you get it wrong, it's okay. Who wants another minute? Hey, on the test, I will not give you any diagrams, and the diagrams are the hardest part. Once you figure out the diagram, it should be pretty good after that. So let's see what this looks like. Or do we want another minute? Anybody want another minute to try? Want another minute? Okay. How many people think they were able to draw it? Maybe? Okay. All right. So it says a boat travels north 28 degrees 15 minutes east for 55.3 miles, then north 61 degrees 45 minutes west for 94.6 miles. Find the bearing from the starting point to the end point. All right, so let's get started. So here's my start point, and we are traveling northeast. So I have my north and my east, and this will be my middle point. So now we are traveling northeast for 55.3. Then what's happening, I guess I should have moved this down a little bit more. All right, that's fine. I'll just put it here. Okay, there's my midpoint. Then we are traveling northwest for 61 degrees and 45 minutes. So again, we have our north line, but now I'm going west, and that's for 94.6 miles. And this is where I end. So this is, oh, I forgot to put my angle in there. I just put the distance. So this distance was 55.3. My angle was 28 degrees, 15 minutes. This was 61 degrees, 45 minutes. And the distance we moved here was 94.6 miles. All right, find the bearing from the starting point to the end point. So we always look for where it says from. So it says from starting point to the end point. So what does that mean? Well, I already have my north line, right? Definitely going north. So now we're going north to my end point. And we want to find this angle. How many people had that diagram or something close enough? Good. Not bad. Okay, so I'm going to extend my two north lines. Why do you think I'm extending my north lines? Because they are parallel. I don't know if it's going to help me, but it might. Let's go and try to find where our right angle is going to be. And move this 94.6 outside. There we go. Okay, so first things first. I know that this angle, hold on one second here. I'm trying to, okay, so I know that this line, let's highlight them, this line and this line are parallel. Since those two lines are parallel, I see a Z. I'm not sure how much it's going to help, but it might. Do we see this Z right here? Right, so that's 2815. It helps me a little bit. Well, actually helps me a lot. It helps me find, let's call this angle 1. It helps me get closer to finding angle 1. Does anybody see how I can now find angle 1? You got it. So this yellow line is a straight angle. This is a straight angle right here. And I have this angle and I have this angle. Won't all three of these angles make that straight angle add up to 180 altogether? So I'm going to add and then subtract from 180. So we're going to have 6145 plus 2815 is going to give us 8960. What's 60 minutes? 1 degree. So isn't that 90 degrees right there? So that means my angle 1 right here is 90 degrees. You know you win when you find that right angle. After that, it shouldn't be a problem. So now I have, let me pull apart this triangle. Here's my right angle. This is 94.6. What's up, Leah?
Isn't the like 28 15? Isn't that outside the triangle?
The 2815.
Like,
So here's the big triangle, right? This line is splitting that angle. So it's splitting that start angle. So that 2815 in the Z comes outside of the triangle, but it helps us ultimately find this angle 1 because this yellow angle right here is a straight angle. So 6145 plus angle 1 plus 2815 makes that straight angle, and angle 1 is inside of the triangle, which helps us out. Okay, so now we have our end, we have our mid, and here's our start. So now let's see, I have the 94.6. I had another measurement. Start to the midpoint is 55.3, or the middle point. Now I need this whole angle. I'm going to call this X. This is X. And once I find X in this triangle, can I then go back and subtract 2815 from X, and that will give me my theta that I need? All right, so that is the plan. So we're going to solve for X. I'm going to use the opposite and the adjacent. So the tangent of X is equal to 94.6 over 55.3. No, because I'm using this big triangle. Let me shade it. So I'm using this blue triangle. And the reason I'm using this blue triangle because ultimately I need to find theta. And if I just use this little Even though it's still a right triangle, if I use this little right triangle, it's not going to help me get theta. So now we're going to take the inverse of both sides. So the inverse tangent of 94.6 over 55.3. Let's go degrees and minutes here. I'm going to say x is 59 degrees and 41 minutes. So now, if this whole angle is 59 degrees and 41 minutes, how do I find just theta? Subtract what from it? You got it. So then theta will be 59 degrees and 41 minutes minus 28 degrees and 15 minutes, which will give us 31 degrees and 26 minutes. But I'm not done. So it's saying find the bearing. So with the bearing, I need direction. So here's my start, here's my end. So from the start to the end, am I going north or south? North. Am I going east or west? West. So what we're going to do, our bearing, oh, I don't think I put direction on the other one. We got to go back and do that. Our bearing is going to be north 31 degrees, 26 minutes west. We need to give it direction. So let's go back because I forgot to do that before. This bearing of 5841 from A to C was south what? From A to C? Southeast, right? From A to C was southeast. So this bearing was south 5841 east. Bye. All right, guys, try to set up this one. Oh, I'm sorry. How far back? That good? All right. Try to set up your diagram for this. Who wants another minute? No? We're ready? All right, last problem. So, a plane leaves the airport and travels 300 miles per hour for 3 hours on a bearing of north 36 degrees 24 minutes west. Then it turns and flies at the same speed for 7 hours on a new bearing of north 26 degrees 36 minutes east. Find the bearing of the plane from the airport after the 10-hour trip. All right, so let's see what's happening here. So I'm going in the middle of my page. Here's my airport. And we're leaving the airport and we're traveling 300 miles per hour for 3 hours on a bearing of north 63 degrees 24 minutes west. So we're going north and then west. All right. Then it turns and flies at the same speed for 7 hours at a new bearing of north 26 degrees 36 minutes east. All right. So if we're traveling a constant speed of 300 miles per hour, we're first traveling 3 hours. That's to this point right here. Then we're traveling 7 hours. Don't you think we're going to get a lot further away in the 7 hours? All right, so what's happening here? So we are going straight up, and then we're going north east. I should have moved this down lower, but it's all right. I'm just going to redraw this whole diagram lower just to get it to look better. So we're north, west, then we're going north, east. All right, and so this northeast, we are 26 degrees, 36 minutes. All right, find the bearing of the plane from the airport. So from the airport to the plane. So what bearing do I want? I want the bearing from the airport to the end. Now, I already have my north line that I'm still going to use for my airport. So now I'm going to go north and then east. All right, so this is what I want to find. I'm going to call it theta. So once we get our diagram, what's the next thing we start looking for? What's the next thing we always look for? The right angle. Yep. Oh, I forgot to label. Sorry, I forgot to label our distances. Sorry, from the airport to this point right here, we traveled 300 miles per hour for 3 hours. How will I figure out how many miles I traveled during that time? I heard it. Multiply. So we're 300 times 3, which is 900. So this is 900. And then we're going to be on this end over here, we're going to do 300 times 7, which is 2100. All right, now we find our right angle. What can we use to try to find our right angle? The north lines. Okay, using our north lines, do you guys see, let me highlight. Do you guys see the C here? laying on its back, sort of. And what do we know about the angles in the armpits of the C? They have to be supplements. They have to add up to 180. So it's this full angle plus this full angle. Those two angles have to add up to 180. Notice I put different loops around them because they're not congruent. We just need them to add up to 180. So what does that mean? I'm going to call this X. So that means 26 degrees and 36 minutes plus 63 degrees and 24 minutes plus X has to equal 180. So if you add these two together, 26, 36, and 63, 24, what do you end up getting? Yep, which is 90. So 90 plus X equals 180, so X has to equal 90. So that means this is a right angle. All right, we're getting there. So now I'm going to redraw this triangle. So here's my end, here's my airport. So, oh, I drew this right angle bad. Try this again. There we go. All right, so we know this is 2100. We know this is 900. We know this is a right angle. Now, I will highlight. We are using this blue triangle right in here. My end game is to find just theta. Am I able to find just theta using this blue triangle? Is theta a full corner angle of the blue triangle? No. Since theta is not a full vertex corner angle of the triangle, I can't find theta using this blue triangle. But see that full airport angle right here? This whole thing right here, if I call this y, can I find that full angle y? And if I find that full angle y, what can I do? Subtract 63/24, and that will give us theta. So that is the plan. So let's call this y. And we have opposite and adjacent. So we are tangent of y equals 2100 over 900. Y will equal the inverse of tangent of 2100 over 900. I will tell you if we do that, we will get y is equal to 66 degrees and 48 minutes. Now, what do I do to find theta? Subtract. Theta will be 66 degrees and 48 minutes minus what? 63/24. And that's going to give us 3 degrees and 24 minutes. Because I'm finding a bearing, I have to make sure it's acute. Is it acute? Yes. What else do I have to put with it? Its direction. So from the airport to the end, I'm going north and east. So our bearing will be north 3 degrees, 24 minutes east. All right, we're done.